AB Calculus AB, Unit 9, Day 5, Office Hours. These are the answers. Multiple choice questions at the top. Pause the video if you'd like to check. Okay, assuming you guys have checked them. Let's see if we can do these. Gotta show work. Okay. Figure below shows a graph of velocity of a moving object as a function of time. At which of the marked points is the object farthest to the right? Now, remember that if you integrate velocity, you get displacement. So it's moved, and if it's positive, that means it's moving to the right. So here, these are positive velocities. The object's moving to the right. So at this point, it's definitely more to the right than when it started, right? And now it's below here, so that means it's moving left. And so for sure, this whole time, anywhere it is, it's going to be less than that. This is the furthest to the right. Is that C? 2. Figure below shows a velocity graph. At which of the marked points is the speed the greatest? Now, speed is the absolute value of velocity. So where's the graph the highest? Right here, D. Because it's absolute value. I'm looking for the biggest speed. So it's going to be D. Right. Number 3, the graph below shows the distance from a reference point of a particle moving on a number line as a function of time. Which of the points marked is closest to the point where the acceleration first becomes negative acceleration first? Well, it's concavity, right? So this is concave up. So this is positive acceleration, and this concave down, so that's negative acceleration. So first becomes negative, I would say, would be C. Okay, number 4, a skydiver has a negative velocity while falling from an airplane. Before the skydiver opens the parachute, her velocity decreases quickly, then levels off due to air resistance. Which graph approximates acceleration of the skydiver? So acceleration is constant generally due to gravity, but it's getting less and less as her velocity approaches terminal velocity. And her acceleration is, the velocity is negative, and it's getting more negative. So that's a negative acceleration. So I would say it's got to be something that's going towards a zero acceleration. This is an acceleration graph. This is acceleration equals 0. It's got to be approaching 0. It's got to be much more negative at first, and then getting closer and closer to 0. Number 5, particle moves on the x-axis, so that at any time t is velocity. So giving you velocity, initial condition, which of the following is the expression for the position? So x is going to be the integral of x prime, which is going to be the integral of velocity, which is going to be the integral of sine 2t. Now you can use substitution here. I hope you're getting comfortable knowing that, okay, well, it's going to be cosine 2t plus c, but extra 2 is going to pop out, so I can put a 1/2 there and make it negative. And then if we plug 0 in, that should give us 0. Cosine 0 is 1, so c equals 1/2. So our expression for t should be negative 1/2 cosine 2t plus 1/2. Negative 1/2 cosine 2t plus 1/2. So D. Okay. 6, particle moves on the x-axis in such a way that its position at time t is given by So here's position for values of t is a particle moving to the left, so that'd be negative velocity. So I get to find the velocity equation. It's going to be 15t squared minus 75t. Well, 15t to the fourth, 75t squared plus 60. And you set equals 0 and solve. So I think we could we definitely take a 15 out of everything. That would make values a lot smaller. And then I think we're going to factor, this is going to be t squared. It's like a trinomial, quadratic trinomial, but it's quartic, but it's the same kind of pattern. So we get 4 values. If you put on a number line, do a line test. This is the velocity number line. Test t equals 3. It's going to be positive, negative, positive, negative, positive. So we're saying moving to the left would be here and here. So negative 2 to negative 1. And then 1 to 2. Now, should we include the endpoints or not? They're not going to trick us in that. Technically, we shouldn't have negative time. So it really should just be d. No negative time. Right. Okay, number 7. Velocity of a particle moving along the y-axis, t greater than 0. The particle moves upward until it reaches the origin, then moves downward. The position of the particle at any time t is given by. So we're trying to find the position equation, and somehow we should have some. You got to find the c value. That's a hard part. So it says particle moves upward until it reaches the origin, then moves downward. So the origin is going to be y equals 0, then moves downward. So, okay, so this is interesting. When y equals 0, velocity equals 0. So somehow we're going to use that. Now, so this is y-axis, so we could say yt equals y prime t dt, which is going to be the integral velocity along the y-axis. So it's going to be the integral of 8 minus 2t dt. It's going to be 8t minus 2t squared over 2 plus c. So, I mean, we could probably eliminate some of these. It should have a negative t squared. That's out. That's out. Negative 1t squared. Positive at. Okay, so I think all the others are good. Now, if y equals 0, let's find the time when y equals, well, we don't even have the equation. Let's find when the velocity equals 0, because it's got to turn around. T equals 4, so that's the time when the velocity equals 0, which is also when the position is 0. So that's our initial condition. So this one's definitely tricky. So if we plug 4 in, we should get 0. So it's 32 minus 16, that's 16. So C equals negative 16. So our final equation for y should be 8t minus t squared minus 16. There we go. That one's a little tricky to get the initial condition. Number 8, a particle moves along the x-axis in such a way that its position at time t is given by, so given the position equation, what's the acceleration at 0? Well, we got to find the acceleration, so we got to take the derivative to get the velocity, which I think we should just do quotient low d high minus high d low all over low squared. Clean it up. -1 minus t minus 1 plus t over 1 plus t squared. T's cancel out, so it's -2 over 1 plus t squared. Now, I don't think I want to do quotient for the next one, because I think we could easily do just power rule like that. So acceleration is +4, 1 plus t to the -3, or 4 over 1 plus t cubed. So we're going to plug 0 into that. And we get 4. Oh, yeah, there we go. See? Okay. Number 9. A particle moves along the x-axis so that anytime t, its position is given by, so given position, we want the acceleration at that time. So we got to find the velocity. It's going to be 1/2 cosine t minus 2 sine 2t. And then the acceleration is going to be -1/2 sine t minus 4 cosine 2t. And then we'll plug pi over 2 in. So that's going to be 1, and that's going to be -1. So we're going to get 3.5 or 7/2. Okay, there you go. Number 10, position particle on the x-axis, t is greater than. So they're giving you a position. The average velocity is what? So average velocity is average derivative position. So it's just the slope of the secant line on the position curve. So xe minus x1 over e minus 1. It's going to be natural log of e minus natural log of 1 over e minus 1. That's going to be 0. So that's going to be natural log of e over e minus 1. Oh, but natural log of e is 1, right? So that's 1 over e minus 1. Okay. Number 11, a particle moves along the x-axis, so anytime t, so give me position, what time t is the which time is the average velocity 0. So we're going to find the average velocity, write an expression for it. X at some t minus x0, I'm assuming. And it's going to equal 0. So then that would be 3t cubed minus 18t squared plus 24t all over t. Gives you 3t squared minus 18t plus 24 equals 0. So now we can factor it. 3t squared minus 6t plus 8 minus 2 minus 4. 2 and 4. So 2 and 4, but here's the tricky thing. Well, would we include 0? I kind of feel like, oh, did I make a mistake? No. Okay. Well, in this scenario, it'd be when the top is equal to 0. And so if we did that, there'd be an extra t here, but that would give you 0 over 0, which is like indeterminate form. I mean, I'm thinking 2 and 4 are the best. Times 0, you get division by 0. So I think I did put E as the answer, but 12. A particle moves along the x-axis at any time t. Its position, what values is the velocity of the particle increasing? Velocity increasing. That means the derivative velocity is positive, which means the acceleration is positive. So we're looking for positive acceleration. So we should find the velocity first. So I'm going to do product rule t plus 1 times 3t minus 3 squared times derivative of what's inside is 1 plus t minus 3 cubed times derivative of t plus 1 is 1. So would it be worth it to go ahead and just multiply this all out? Or do we just keep it going with some more product rules? I mean, we could do another product rule. We say, okay, well, this is going to be t plus 1 times derivative of this is going to be 6 t minus 3 to the first. Derivative inside is 1 plus, so we're doing another product rule here. 3t minus 3 squared times derivative of t plus 1 is 1 plus 3t minus 3 squared. So that's your acceleration. And we want to set equals 0 and do a line check. Now, before we multiply that all out, maybe we could factor right now. I think they all have a t minus 3, right? And we take out, and then this one has a 6t plus 6 left over. This one has a t minus 3 left that you multiply 3 into, so that's 3t minus 9. And this one has t minus 3 left over also. You've plus 3t minus 9. So what do we get? 12t minus 12. So we could factor the 12 out. And we get t equals 3 and 1. Then we got to do a line check. So 1, 3, test, t equals 4, positive, negative, positive. So we want to know, when is the velocity increasing? So if we're only assuming positive times, we'd say 0 to 1. And we would include the end points usually because of the word increasing. And 3 to infinity. Or t is between 0 and 1, or t is less than 1, t is greater than 3. It sort of ignores the whole negative issue, but that's the closest one. So all right. Number 13, particle moves along a straight line. This is velocity. How far does the particle travel? How far? That's distance. So finally something new, something from this unit. So we need to integrate from 1 to 3, the absolute value of t squared. We want to find the zeros. We do line check. I kind of like the table approach, but I think this one wouldn't be that bad because it switches signs at 0, which just doesn't even matter to us. So we could just say this is 1 to 3 of t squared. In fact, t squared is always positive, right? So the absolute values don't even matter in that situation. So t the third over 3, 1 to 3, 9 minus 1/3, 8 and 2/3, 24 26/3. So I don't really feel like the table that is like a big help on this one, but I mean, if you want, there are no turning points where you're trying to evaluate it. So I mean, you could use the table, not the huge benefit it usually is. Okay, next one, particle moving. That's its x, t is greater than 0, for which value is the speed the greatest. So this kind of sounds like a string value theorem problem. Probably want to look for max or min velocity, because the max velocity might be the greatest speed. The min velocity might be the greatest speed. So I think if we look for max min velocity, that'll help us find what we're looking for. So velocity equals 4t cubed minus 30t squared plus 58t minus 36. And the derivative of this, which is acceleration, is going to be the critical points. Critical points for velocity. So it's going to be 12t squared minus 60t plus 58. We'll set that equal to 0. And we'll see if we can factor this. We could take a 2 out of everything. This is going to be ugly. We have to do quadratic formula, I think. I don't think we can factor this. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So 24 times 29. 4 times 9 is 36. Carry the 3 to 8 is 11. 0. 18 carry the 1 to 4 is 5. 6, 9, 6. 900 minus 696. Which is going to be 204. We take a 4 out of this, 51. So, I mean, these are, I guess, critical points. And it's not pretty. I mean, this would be about 7. It's going to be about 22 over 6 is 11 thirds is 3.7. And the negative one is going to be like 8. It's going to be like 4 thirds. It's going to be like 1.3, 1.4. You know, and if we were to do like a table, now all these answers said for which way is speed the greatest. So it's not necessarily the actual greatest, but we could, I guess, of what you choose from, which one is the greatest? Speed. So it says you can use a calculator. So I guess you could use it to calculate these values. 4 minus 30 plus 58 minus 36. 66 negative 8 is negative 4. And then 2 is 32 minus 120 plus 106 minus 36. So that's going to be 138, 18, negative 18. Is it negative 18? It should be 116. Okay, so 148, 28, negative 8. Put 3 in. 4 times 27 is 108 minus 270 plus 50, 174. Numbers are getting big. I mean, so we could just calculate all these. And so this is going to be 282, so that's 12 negative 24. If we plug 4 in, 4 times 64 is 256 minus 30 times 16 be 480 plus 4 times that would be 232 minus 36. So that's 488. That's 8. It's negative 28. And if we plug 5 in, 125, 250, 500 minus 30 times 25, that'd be 75 with a 0 on the end, plus 250, 290, minus 36, so that's 790. It's 40 minus 8, that's 4. So which one is the greatest speed? It's going to be the biggest one, positive or negative. So it's going to be at 4. All right. Okay, number 15, particle moves along the x-axis. This is its position. For what value does t have? For what value of t is the velocity negative? It says we could use a graphing calculator. So, I mean, we could just find the velocity function, 3t squared plus 22 plus 6 pi sine pi t. Because I don't think we're going to solve that by setting equal to 0. So on the graphing calculator, let's see. Let's just graph this and say, for what value t is it negative? I mean, you could just plug each one in and see if you get a negative answer, but okay. 3t squared plus 22 plus 6 pi sine pi x window. I mean, 0 to 2. Just do a negative 10 to 10. Let's see. Actually, in reading mode. Oh, there's a little value right there. So this is the graph. And I mean, it looks like it's always positive. And as you go more and more to the right, this term dominates. So that's just going to get bigger and bigger and bigger. So I guess we're going to go with it's not negative, and we're only considering positive times. So yeah, we have a little response problem here that is note calculator. Graph of V, particle moves along the x-axis, so its velocity times t 0 to 6 is given by a differentiable function v. Might need more of that. Graph shown above, velocity 0 is 0, t equals 0, 3 and 5. 0, 3 and 5. That seems clear on the picture. Graph has horizontal tangents of 1 and 4. Horizontal tangents at 1 and 4. Should be acceleration equals 0. The areas of the regions bounded by the t-axis in the graph of V on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. So the area of this is 8, 3, and 2. So you might need to use those. At time 0, the particle is at x equals negative 2. So that's the initial condition. So that's all the information we have. A says find both the time and position of the particle when the particle is farthest to the left. Justify your answer. Now, sounds like extreme value theorem. That's how you're going to justify your answer. Farthest to the left is the same as min x. Okay? So this is the absolute minimum that we're trying to find. So our endpoints are given to us, 0 to 6. So that's nice. we got to find a critical point. So critical points are going to happen when you take the derivative of x, which equals velocity. Say equals 0 undefined, which is what we have on our graph. We know that that happens at 0, 3, and 5. These are your critical points. So then I would make a table, and we're going to plug these into the position function. Now, here's the deal with position function. We have the derivative of position, and we know the fundamental theorem of calculus says, well, we're going to get x over the top limit is. Now, they gave us one value. They told us that 0. So we're going to do 0, 3, 5, and 6. We already know at time 0 it's negative 2, right? They just told us that. For all the other ones, we can say, okay, we're going to put 0 to whatever time in here. So it's going to be xt minus x0. So fundamental theorem of calculus says, okay, if you want xt, it's going to be x0, which we already got was negative 2, plus the integral of 0 to t of the derivative, which is the velocity. So, and also the integral of velocity is the area. So the next one's going to be negative 2 plus negative 8. It's negative because it's below the x-axis, and the object is moving to the left, so its position should decrease. And we get negative 10. The next one, you could actually just piggyback off this one and say negative 10 plus 3 is negative 7. And then you piggyback off this, negative 7 minus 2 is negative 9. So we're looking for min x. It's going to be right there. So we're gonna put the answer. We're going to say, okay, the minimum position of the particle is negative 10 at time t equals 3. I don't think there's any units on this. By extreme value theorem. By checking endpoints and critical points. And they said they wanted both time and value. So that's where my always giving the value and location pays off. I had to get both of them. Okay, now point-wise, this is out of 9 points. Okay, this is 3, 3, 1, and 2. On this problem, you got 1 point for integrating the velocity. You got 1 point for finding the critical points. And then you got 1 point for the answer and explanation. Justification. All right. We did some problems like this last semester where I said, hey, the area of this curve is actually going to tell you how far you go. But in those ones, they didn't actually give us the values like they did here, which is a little more common nowadays. B, for how many values of t is the particle at x equals negative 8? Explain your answer. So we're saying, what are the values of t for when x equals negative 8? Or actually just how many? Well, okay. We actually just found a bunch of values right here, right? And so it's got to hit negative 8 between these two. It's got to hit negative 8 between these two. And it's got to hit negative 8 between these two again. That's called the intermediate value theorem. So I'd say at least 3 times. So I'm going to say the particle is at negative 8 at least 3 times by the intermediate value theorem. So we could say more specifically between time equals 0, where x equals negative 2, and time equals 3, where x equals negative 10, and between time equals 3, where x equals negative 10, and time equals 5, where x equals negative 7, and between t equals 5, where x equals negative 7, and t equals 6, where x equals negative 9. Now, to use the intermediate value theorem, there's one condition. It has to be a continuous function. Since the velocity is differentiable and therefore continuous, the position must also be continuous. Something like that. Okay, C says on the interval 2 to 3 is the speed of the particle increasing or decreasing. Now, this is the way they say it. Speed increasing or decreasing. This means speeding up or slowing down. Okay? Increasing is speeding up, decreasing is slowing down. So we got to give a reason for our answer. So, looking at the graph, this is velocity, right? So this is velocity is negative, velocity is positive, velocity is negative. And the slope of this graph is the acceleration. So here, acceleration is negative, here, acceleration is positive, and here, acceleration is negative. So we're trying to figure out where is this from 2 to 3 specifically, is the speed increasing, decreasing? Well, velocity is negative, acceleration is positive, so the speed is decreasing, it's slowing down. So we're going to say on 2 to 3, the speed is decreasing since the velocity and acceleration are acting in opposite directions. And then you probably want to get more specific how you know that. Since the velocity is negative, which is clear from the graph, and the acceleration is positive, and we could explain how we know that velocity is increasing. Something like that. All right, D. During what time intervals, if any, is the acceleration of the particle negative? So we pretty much already found that when we say on the interval 0 to 3. No, actually not that. So we're looking for negative. So that's actually like 0 to 1.5. 0 to 1. No, 0 to 1. Because this is where that's where the horizontal tangent is. So 0 to 1 and 4 to 6. the acceleration of the particle is negative. How do you know? Since the velocity, the slope of the velocity is negative. Another way to say that, since the velocity is decreasing on those same intervals. Woo! All right.